All right, and next we're talking about solids, which is probably the most diverse state of matter that we will talk about. So there are two broad types of solids. The first is crystalline solids, and the second is amorphous solids. The biggest difference, really the only difference, is that crystalline solids are organized. The particles have a specific structure, a repeating three-dimensional pattern of particles, whereas amorphous solids don't have a structure. It's like you just kind of clumped all those particles together. They're close, they're solid, but they're not as organized as crystalline solids. Crystalline solids can be broken down into 4 other subgroups, which are ionic solids, metallic solids, covalent network solids, and molecular crystal solids. So first we'll talk about ionic solids. Ionic solids are pretty much any ionic compound, which is made up of cations and anions. So remember, cations are atoms that have lost electrons, so they're positive, and anions have gained electrons, so they're negative. So ionic compounds are different than molecular compounds because they don't actually have a covalent bond between them. They're actually just attracted to one another because opposite charges attract. So it's not really a bond, an ionic bond, it's more of an attraction between particles. They don't have to be just between two different cations that come from elements or anions that come from elements. There are also polyatomic anions that can be part of the ionic solid as an anion or a cation. So this is an image of sodium chloride, NaCl, but this could easily be representative of an ionic solid with a polyatomic ion in it as well. The properties of ionic solids is that they're hard, they're brittle, so they break apart easily if you were to apply a force, and they only conduct electricity when molten or dissolved in liquid. The reason for that is for electricity to flow, there has to be charges that are able to move. In an ionic solid, there are charges, positive and negative charges, but they aren't able to flow or move. If you melt that solid or you dissolve it in water, then you can conduct electricity. Next we have the metallic solid, which a metallic solid, any metal or alloy, which is a mixture of metals or solution of metals. A metallic solid contains metal cations that are surrounded by a sea of electrons. So in a metallic solid, we have atoms of metals, but their electrons aren't associated just to one atoms. They truly share all their electrons. So electrons are free to flow to other atoms in that metal. For this reason, metals do conduct electricity very well. They are malleable, which means you can hammer them into different shapes. They're lustrous, which means that they're shiny. They're ductile, which means they can be made into wires. And of course, they conduct electricity. Typically they have a high melting point, but metals actually have a wide range of melting points. So mercury, for example, at room temperature is a liquid, but most metals have a higher melting point. The next type of crystalline solid is the covalent network crystal. So in this, just like ionic solids, atoms are organized in this crystal lattice, which means an organized 3D structure, and atoms are bonded together to neighboring atoms covalently. So they share a covalent bond, not an ionic bond. Examples are diamond, which is made of just carbon, quartz, and your metalloids will also form a covalent network crystal. Typically they are also hard and brittle. They have high melting and boiling points because covalent bonds are really, really strong. And they never conduct electricity. So they don't have charges that flow throughout them, even if they are liquefied. And then we have molecular crystals, which is like ammonia. Any of your noble gases will form molecular crystals, and water or ice. So molecular crystals are a lot like the covalent network crystals, except for those dots in this structure are molecules instead of atoms. So the molecules are arranged in an organized crystal lattice again, and this time they're held together by weak intermolecular forces. So the molecules do not have covalent bonds between them. This is where the intermolecular forces come into play. Okay, so there's like hydrogen bonding in water. You'll also hear dipole-dipole or dispersion forces, and we'll talk specifically about those different intermolecular forces once school resumes in the fall. Molecular crystals have relatively low melting and boiling points because intermolecular forces are pretty weak, and they are also poor conductors of electricity. And then finally, we talk about amorphous solids. So this image here kind of shows you the difference between crystalline and amorphous solids. Crystalline, those little particles are nice and organized in a 3D repeating pattern. Amorphous, it's just kind of like you clump them together. They fit together pretty nicely, but there's no like repeating pattern or anything. Because of this, since they don't have an organization or a repeating pattern, they don't have distinct melting or boiling points. So different parts of this solid actually start to melt at different times. So if you've ever seen like plastic melt, or if you've ever seen glass makers when they're making like different shapes with glass, you'll notice that like it bends and you can like reform it. And that's because there is no distinct melting or boiling point. They don't have points of cleavage, so they're not brittle. So if you were to take a big chunk of salt, beat it with a hammer, you always get these cubes of salt in varying sizes. Even if you go smaller and smaller and smaller, it's always this microscopic crystalline structure that is basically a cube. With glass, if you were to take a hammer to glass, it doesn't shatter into nice, equal cube pieces or anything like that. It's very random. You get big shards of glass, you get small, tiny little pieces, so that they don't break neatly. It's a random shatter more than anything. And again, some examples are plastic, rubber, glass, and gels. All right, so that's a quick review of the different types of solids. Let me know if you have any questions.